This is a video to go along with a blog entry that's going to discuss how to use Forth to better understand programming microcontrollers such as the Arduino Uno. The reason why I like Forth are its three principal values. It's fast. It's fast from an editing perspective or program creation perspective, and it's fast from an execution perspective. If you look at the comparable speed, board speed language comparison that I've got on the blog, you'll see that Forth ranges anywhere from half as fast to twice as fast as C, far faster than MicroPython. Like MicroPython, it's highly interactive. You can use it as you would a Python REPL. The difference is that the third point of Forth, which is the extensibility, is that you can very easily create a word and then use that without a lot of effort in Forth. And so that's what those three things I want to talk about and demonstrate today. So on your screen, you see four windows, and each window is important to the development of Forth and understanding how a program works in Forth. In this case, we want to look at a timer counter, and the best way to take a look at a timer counter is to make sure that you've got an oscilloscope. And so that's what this particular screen or window does, which is it shows us the digital output of the timer counter 1, which is the Arduino pin 10 or Arduino Uno pin 10. The next window is our terminal, and this is what we would use to upload a program to FlashForth. I've got a program called up.py, which is a Python program, and it sits there and waits for a response from FlashForth. And if the response does not have a question mark in it, it says, okay, I know I compiled that line, so I'm going to send the next line. It checks for blank lines, it checks for comment only lines. So it's pretty fast, and as you can see, a 282 line program, which includes comments and some blank lines, compiles in about 4.5 seconds. And so that's sufficiently fast. It's easily as fast as compiling on C and putting that on the Arduino Uno. And so we use that one, but not so much in this particular demonstration. The one we will use quite a bit is the serial window, and this is the window that interacts with FlashForth. And so if I go to that window and I say 2, 3, but those two words are two numbers on the stack and then use the word plus, it says it puts 5 on the stack, and if I use period, it prints 5. And so you can see that I'm using Forth, that way. And then finally, we're going to look at this particular program. And so this is the programming editor I use, Sublime Text, for creating text files that I upload, because you don't want to type just the same way you wouldn't do it in MicroPython. You don't want to continually just type programs in via the serial port. And so you can see that this program is really very simple. It has 3 sections. The top section are the comments that remind me how to use timer counter 1. The middle section are the addresses of the control registers that you need to set up in order to use timer counter 1. And then the last section is a word I call CTC. CTC is a word that takes a 16-bit number on the stack and it writes it to OCR1A, both L and H, and that value determines the frequency of the counter timer. And so if you take a look at the comments, you can see on line 25, if you enter a 31, then you'll get 31.25 kilohertz. And if you enter the value 1023, then you'll get the value of 976 hertz. So let's check that out. That word is already in the FlashForth itself. I've already uploaded it. Just make it easier for us to use. So we'll go back to serial and we'll type in 31 CTC. We put 31 on the stack and then we give it the word CTC. And then we go back to our waveforms and we can see that, yep, it's 31.212. I'm going to do this to show you that it gives you a little better indication of what the signal looks like. But if you were to take 30, it shows 31.211 as the frequency, which is about 0.1% off of the 31250. So I'm pretty happy with that. The discovery, the analog discovery is probably not that accurate either. No disrespect for the analog discovery. So let's also try the 1023. So if we go, and I'll just put it in all four Windows modes so you can see it for all for a moment. I'll go 1, 0, 2, 3, and then CTC in the bottom right hand corner. Then I hit return, and let's auto set again to see, and it will show you that it's at 975.37. So again, it's about 0.1% off, but it's really close to 976 hertz. And so the value here is that now you can play around and see what the signal looks like. It also shows that the value, even though it's not showing the values correctly here, it really is a 50% duty cycle, because you can see how symmetrical it is. So and just then entering, any number in. You could enter in, you can enter any number up to 65,538. So we could enter 32,000, 3,200, 32,000 CTC, and that's going to give us a really low frequency, because now it's got to count up to 32,000. And that looks like it's around 31 hertz, and it's still pretty much a 50%, or it is a 50% duty cycle. Or if you hit show one more, I'll show a number. If you go to, for instance, 24, I think that gets us really close to, I believe it's 40 hertz. Let me take a look at that. And so that then provides, 39.949 hertz. And so it's a great way to understand. And so you're using the interaction of Forth in the serial terminal, much as you would with MicroPython. However, you get the speed of C, and not the speed of MicroPython that with Forth. And then you get extensible, because you can use that CTC word. Not only is it really easy to use typing into the terminal, but you could use it in any program, and then you could build additional programs around it. And as for what I do, is I actually use this to output frequencies to a ultrasonic transducer, and so I can range the frequencies to whatever I want there.